See, today's topic is HLB scale. HLB nothing but Hydrophilic-Lipophilic Balance scale. See, this Hydrophilic-Lipophilic Balance scale first, see this HLB scale first developed by the Griffin in the year 1949. They have asked in one of previous year GPAT question. Next, if we people know about the HLB value of the surfactant, then what is the use of this HLB value? See, if you people know about the HLB value of the surfactant, it simply indicates the solubility of the surfactants. Means whether that surfactant is hydrophilic nature or lipophilic in nature. See, for example, if one of the surfactant I have told like salts of fatty acid, sodium salts of fatty acid, the HLB value is 10. Then it simply indicates it is hydrophilic in nature. See the value above 8 of HLB value. If the HLB value is above 8, then it simply indicates that particular surfactant is having hydrophilic in nature. See, for example, if I have told the surfactant X that is having the HLB value 5, then simply it indicates it is lipophilic in nature. So this is the thing we can be derived from this HLB scale. Next, when it comes to the HLB value of the different surfactants, first we have focused on anti-foaming agents. Anti-foaming agents that is having HLB value 1 to 3. What are the examples of anti-foaming agents? Means fatty alcohols. For example, sterile alcohol. Sterile alcohol that is having C18 carbons. Next one is cetyl alcohol that is contain C16 carbons. Next one is cholesterol that contains C27 carbons. See, these are the anti-foaming agents. What is the HLB value of anti-foaming agent is 1 to 3. These are purely lipophilic in nature because of presence of 18 carbons, 16 carbons, 27 carbon atoms. So these are purely lipophilic in nature. Next comes to the liquid paraffin. See, this liquid paraffin they have also asked in the previous year GPAT. What is the HLB value of liquid paraffin? Liquid paraffin HLB value is 1 to 3. Next one is water in oil emulsion or water in oil emulsifying agents. See, if we people want to stabilize the water in oil emulsion, see here oil is a continuous phase. See, when the oil is a continuous phase, oil is lipophilic in nature, definitely we people need to select the lipophilic surfactants. Means the surfactant is lipophilic in nature. What are those lipophilic surfactants? Means divalent or trivalent. See, +2 or +3. Divalent or trivalent metallic soaps will act as a lipophilic surfactants that can stabilize the water in oil kind of emulsions. See why it is lipophilic in nature. We can discuss in detail in the further slides. Next, it comes to the oil in water. See if the water is a continuous phase, then we need to select the water soluble surfactants. Water soluble surfactants nothing but hydrophilic surfactants. What are those hydrophilic surfactants? Nothing but monovalent metal soaps. Monovalent nothing but see sodium, potassium or ammonium. See this is a fatty acid. This is a fatty acid. These are the salts of fatty acids. Next one is triethanolamine. See, this is also fatty acid, stearic acid that contains triethanol. See, three ethyl group containing three ethanol group containing amine. We can call it a triethanol amine soap. Triethanol amine soap. See, why we people are using this amine containing compounds? Why we are not using this sodium or potassium salts? Means this sodium or potassium salts that will form some crystals on the skin after taking the bath. This will form some white colored spots on the skin, so that can be replaced with the amine containing soaps, that is triethanol amine soaps. And these triethanol soaps also having less irritation property compared to sodium or potassium salts. This is completed. Next one is spreading agent. Next one is spreading agent. See, this spreading agent also we can call as a wetting agent. This predominantly can be used in case of suspensions. Spreading agent or wetting agent can be used in case of suspensions. See, what are those examples? Tween 80, that is liquid in nature. Next one is glycerol. Next one is propylene glycol. All these are used as a spreading agents. All these are can be used as a spreading agent. Next one is detergents. See, under the detergents, it will be what are the things that will comes under the detergent is SLS, sodium lauryl sulfate. See, what is the difference between soap? See, this water in oil emulsion, that is also soap here. We can use soaps. For oil in water emulsion, also we can use the soap. But here the case is detergent. What is the difference between soap and detergent? Means soap that is containing a carboxylic acid group, COO group. But here detergent that is containing sulfate group. What is the difference between soaps and detergent? Is soap nothing but that contains carboxylic acid. Detergent nothing but that will contains sulfate group, and their function also different. See, this detergent can be used for the non-living thing. These soaps can be used for the living things. What are the HLB value of this detergent is 13 to 16. Best example is SLS. Next one is solubilizing agent. Next one is solubilizing agent. What is the HLB value of solubilizing agent? Means 16 to 20. What are the examples of solubilizing agent? Means SLS, sodium lauryl sulfate, also acts as a detergent, also act as a solubilizing agent. Next, tween 20 and water miscible organic solvents like ethanol. Water miscible organic solvents like ethanol. See, this solubilizing agent, where we can use this solubilizing agent means in the parenteral dosage forms. Detergents can be used for the washing of clothes. Okay. Soaps can be used for the stabilization of emulsions. Next, spreading or wetting agent can be used for the dissolving of insoluble solids in the aqueous phase, especially in case of suspensions. Next one is first and foremost thing, that is anti-foaming agent. See, what is the foam? Nothing but it is a air in water system. Nothing but entroughtment of air. See, this empty space, this white colored empty space is there, that is air. This blue colored thing is there, that is, see, this is a water. This blue colored thing, that is a water. This empty space, this empty space is there, that is the air. See, this air will act as a dispersed phase. Here, this water will act as a dispersed medium or continuous medium. This is the structure of foam. Means entroughtment of air within the liquid. Air liquid nothing but water. See how this foam can be stabilized. See, this foam can be stabilized with the help of surfactants only. The foam can be stabilized with the help of surfactants. Hence, the surfactants used in the foam we can call as a foam stabilizing agents. The surfactants, if we are using in foam, we can call as a foam stabilizing agent. Okay, see the surfactants that is must and should it is having hydrophilic in nature. See, always we will select the surfactants based on the continuous phase. See here in the foam, what is the continuous phase? Water. If the continuous phase is water, definitely we need to select the hydrophilic surfactant. Hydrophilic surfactants only acts as a foam stabilizing agents. If we people are using anti-foaming agents, if we people are using anti-foaming agent, that is HLB value 1 to 3, those are lipophilic in nature. All these are lipophilic surfactants. All these are lipophilic surfactants. Hence, this will act as a anti-foaming agents, or this can destabilize the foam. If you want to destabilize the foam, definitely we need to use the anti-foaming agent. The HLB value is 1 to 3. If you want to stabilize the emulsion, sorry, if you want to stabilize the foam, definitely we need to use the hydrophilic surfactant. The HLB value is greater than 8. Next one is types of surfactants. What are the different types of surfactants are there? Means one is non-ionic, means there is no charge present on that particular amplifier. Next one is anionic surfactant, that is containing negative charge. Next one is cationic surfactant, that is containing positive charge. Next one is amphoteric surfactant. Amphoteric surfactant, that is contain both positive and negative charges. So these are the different types of surfactants and very much useful in the pharmacy. Now we can observe, see all these are amphiphile molecule. Amphiphile nothing but that contains polar hydrophilic moiety, also that contains hydrophobic moiety. The hydrophobic moiety is due to the presence of hydrocarbons, only carbon, hydrogen, carbon, hydrogen. The hydrophilic moiety is due to the presence of polar function group. Here the polar function group is phosphate group. Next here the polar function group is ammonium group. Here the polar function group is sulfate group. Here the polar function group is this sorbitol, sugar alcohol. Like this, all different amphiphiles means both polar and non-polar portion containing molecules will be there. Now this will be having different properties. One is deuterionic. Deuterionic nothing but amphoteric in nature. See here negative charge. The oxygen contain negative charge. Here the nitrogens contain positive charge. This deuterionic also we can call as a amphoteric surfactant. Deuterionic also we can call as a amphoteric surfactant. Next one is cationic surfactant. Nothing but that surfactant that is containing positive charge. See this nitrogen is there, that nitrogen containing positive charge, hence we can call as cationic surfactant. Next one is anionic surfactant, nothing but negative charge. See here the sulfate group is there, sulfate group that contain negative charge. Hence we can call as a non-ionic surfactant. Non-ionic nothing but we are not at all observing either positive or negative charge, hence these are we can call as a non-ionic surfactants. This is about types of surfactants. Now, cationic surfactants. What are the different examples of cationic surfactants? The first and foremost thing is benzalkonium chloride. Only three major cationic surfactants can be useful in the pharmacy. First and foremost one is benzalkonium chloride. See, this is a benzyl moiety. This is a benzyl moiety. Next one is this is alkyl group. Next, this is also alkyl group. This is also alkyl group. Hence, benz alkonium, alkyl group containing along with chloride. If it is a chloride negative charge, we need to write at the last. If it is a positive charge, for example, if sodium is there, then we need to write at the first. Here we need to write before benzene, we need to write sodium like that. That is a benzalkonium chloride. Next one is citramide. Citramide structure we can get is cetyl nothing but C16 carbon containing. See here 14 carbon, here 1, 15, here 1, 16. 16 carbon containing thing we can call as a cetyl group. Okay, cetyl. Tri nothing but trimethyl. See 1, 2, 3. 3 methyl group. Mide nothing but bromide. Mide nothing but bromide. The brand name of this citramide we can call as a cetab. Okay, so this is about the citramide. This is used as a surfactant in case of detergents. Okay, next one is cetyl pyridinium chloride. See, cetyl group nothing but C16 carbon containing functional group here. Next one is pyridinium. See, if positive charge present on the nitrogen, we can call as a IUM. Positive charged nitrogen, we can call as a IUM. That is pyridinium. Next one is chloride. Next one is chloride. Like that, majorly only three cationic surfactants can be useful in the pharmacy. Next, what are the examples of or what are the uses of these cationic surfactants? If you know about the cationic surfactants, what are the use of these cationic surfactants? See, these cationic surfactants majorly used as a preservatives in the pharmaceutical dosage forms. Sir, how we are using this cationic surfactants as a preservative means if the normally the bacterial cell membrane that is containing negative charge. These are the negative charge present on the bacterial surface. If we have added cationic surfactants, if you people have added cationic surfactants, then that cationic surfactants will bound with the negative charge present on the microorganism. After precipitation of this one, then it will be acts as a preservative. By formation of this positive and negative charged ionic bond, these cationic surfactants will act as a preservative in the pharmaceutical dosage forms, like parenterals. Next one is tablets, emulsions, suspensions. Next, the same cationic surfactants used as a cleansing agent, used as a conditioning agent in hair conditioners, used as a conditioning agent. See how we are using this cationic surfactants in hair conditioners means here first we can consider this is a hair strand. Next that is cuticle. Okay. See this yellow colored thing is oil or dirt molecule. See these are the hairs that is surrounded with yellow colored thing that is the oil or dirt molecule present on the hair. See we need to remove that oil or dirt molecule present on the hair by using the anionic surfactant. Anionic surfactants will act as a cleansing agent, means that will remove the oil or dirt from the hair. That's all. What is the nature of this anionic surfactant? Means the anionic surfactant that is containing negative charge. That is the first and foremost thing. And the tail, head is negative charge. The tail is sharp in nature. The tail should be sharp. Head contain negative charge. Okay. These anionic surfactants that will form micelles. We have already discussed in the previous class. This will form micelles. By forming the micelle that will remove the oil from the air. Next one is conditioning surfactant. Next one is conditioning surfactant. What is the property of conditioning surfactant? Means that should be the polar group that should be contains positive charge. Very important. The polar group or head that should be contains positive charge. Tail should be long. The tail, whatever the tail is there, that should be long compared to anionic surfactants. The tail should be long, that is compared to anionic surfactants. Now we can observe here. See shampoo and hair conditioner. See the shampoo that is containing anionic surfactants. Shampoo that containing anionic surfactants. That anionic surfactant that will forms micelles. That will form micelles. By forming micelle that can remove the oil or dirt molecule from the air. This is the mechanism of anionic surfactants. Why we are using anionic surfactant? That will form micelles. By forming micelle that can remove the dirt present on the air. See, this is the before application. See, after application of shampoo, then what will happen means after application of shampoo, all the all dirt or oil present on the hair can be removed. After washing of hair with the shampoo, the hair will get negative charge. The hair will get negative charge. Why means that the charge of anionic surfactant is negative. Hence, after washing the hairs with the shampoo, the hairs will get positive charge. Now, this positive charged hair that will be forms clumsiness like this. We can observe here. See this positive, negative charged hairs that will be forms clumsiness, nothing but entanglement like this. One hair that will be combined with another hair. Like there is a formation of entanglement. That is after application of shampoo. Then if we people have used conditioning or hair conditioner that contains cationic surfactant, that contains cationic means positive charged surfactants, then what will happen means this is the before after application of the hair conditioner, then we people get the straight hairs. The hairs will be become straight, and that clumsiness can be removed by the application of air conditioners. That air conditioners that is majorly contain the cationic surfactants, but shampoos that is contains anionic surfactants. That is the major difference between the shampoo and air conditioners. After the application of shampoo, there is a chance of clumsiness of the hair. After application of the air conditioner, the hairs will become straight and smooth. See, this is the importance of cationic and anionic surfactants. Next, we can observe now the thing about the cationic surfactant is completed. Now, anionic surfactants. So, what are the examples of anionic surfactants? Nothing but soaps. Soaps. Soaps refers to the sodium or potassium salts of fatty acid. Already we have discussed under the HLB scale. Now we can observe. See, monovalent soaps are two types. That is the monovalent soaps. Monovalent nothing but that contains sodium, ammonium, or potassium. All these are the monovalent soaps. See, all these monovalent soaps, there is a single bond between this sodium and fatty acid. This is a fatty acid. This is a salt. There is a ionic bond present between the fatty acid and salt that can be easily broken by the water molecule. If we have dissolved this salt of sodium salt of fatty acid in the water, then the water molecule, because of polarity of the water molecule, that can easily break the bond present between fatty acid and sodium. Hence, these monovalent soaps are hydrophilic in nature. What is the nature of monovalent soap? Means the nature of monovalent soap is hydrophilic in nature. When it is hydrophilic in nature, we need to use to stabilize the oil in water system. If the continuous phase is water, then we can use hydrophilic surfactant. This is about the monovalent soaps. Next one is divalent soaps. See, when it comes to the divalent soaps, see this calcium, magnesium, zinc, or aluminum that will form two ionic bonds with the fatty acid. That's why we have represented two fatty acid that will form bond with single calcium atom. See, if we have added this divalent soap in the water, the water will not at all break. The water cannot break the bond present, ionic bond present between the fatty acid and calcium. Hence, these are lipophilic in nature. So when the surfactant is lipophilic in nature, we can use it in the water in oil. If the oil is continuous phase, then we can use the lipophilic surfactant. For the stabilization of water in oil system, we can use the divalent soaps. Monovalent soaps we can use for the oil in water system. Next one is under the anionic surfactants. Next one is detergents. See, what are the detergents? Nothing but detergent that is containing sulfonic acid. But soaps that is containing carboxylic acid, here carboxylic acid there, but the detergent that is contains sulfonic acid, SO4. That is a major difference between soaps and detergents. Next, when it comes to this anionic surfactants, see sodium stearate, C18 carbon containing, we can call it as stearate. This is sodium. Next one is anionic. See, detergents are three types. One is anionic. See, negative charge containing detergent. See, positive charge containing detergent. Non-ionic. Ethylene glycol group containing detergent. That is non-ionic detergents. Detergents can be used for the washing of clothes. Soaps can be used for the bathing. Okay. Next one is under the soaps, different types of soaps are there. We can observe here. Luxury soaps. Luxury soaps, example is palm olive. Examples of this one is palm olive. Palmolive. See, this is the one kind of soap we can get in the market. What is the cost of this soap is around 1000. Cost of this soap is around 1000. See what it contains or why the cost of this one is more means it is contains only vegetable fatty acid, vegetable oils. See vegetable oil nothing but that is simply glyceride, triglyceride means this is a glycerol fatty acid. See this is a glycerol moiety that is combined with fatty acid. One, two, three fatty acids are there. If that's contain fatty acids, that is vegetable, that is derived from the vegetable, then we can call it a luxury soap bars. Luxury soap bar that contains only vegetable oil that is derived from the vegetables. That is very high cost. These soaps are very high cost. Next one is tallow or beef fat. See the soaps also can be prepared from the beef fat that contains majorly C18 carbon, oleic acid, C18 carbon containing unsaturated fatty acid. Means that between the carbon carbon double bond, between the carbon carbon there is a double bond in case of C18, oleic acid, C18 unsaturated fatty acid that is oleic acid. This tallow or beef fat that majorly contains unsaturated C18 carbon containing fatty acid. See, this is the soap we can made from the tallow or beef fat. Next one is cheaper soaps. How can we get this cheaper soaps means saponification of tallow. See, if it is a fatty acid, if we have added basic hydrolysis, this is a ester group. If you are doing hydrolysis in the presence of base NaOH, then we will get cheaper soap. See, this cost is around beef fat derived soap cost is around 500. Cheaper soaps cost is around 200 or 100. Just saponification means in the basic environment we need to hydrolysis the ester bond present in the vegetable oils. Next one is transparent soaps. See these transparent soaps that's containing castor oil. Castor oil that is containing major proportions of resinolic acid. Resinolic acid nothing but that is containing hydroxy group. That is containing hydro OH group at C12 carbon. At 12th carbon it contains hydroxy group. Transparent soaps example is pear soap. See this pear soap that is transparent in nature that is majorly contains which acid means castor oil containing resinolic acid. Next one is sodium lauryl sulfate. See, this is very much important. Surfactants can be widely used in the pharmacy or cosmetics. SLS, simply we can call it SLS, sodium lauryl sulfate. See, what is the structure of this one means sodium lauryl nothing but C11 carbon containing 11 C11 carbon containing thing we can call it a lauryl group. Next one is sulfate means SO4, sodium. If it is positive charge, definitely we need to write another first sodium lauryl sulfate. See this sodium lauryl sulfate, this is a hydrophilic in nature. If it is a cation, sorry, it is a anionic in nature, means negative charge present on the present on the oxygen atom. Because of the negative charge present on the oxygen atom, it is act as a anionic sulfate. If any compound that contain positive or negative charge, this is polar in nature, easily soluble in the water. Hence, this SLS is a hydrophilic surfactant. Hence, this SLS is a hydrophilic surfactant, and it is also having the bacteriostatic property. It is also having the bacteriostatic properties. Hence, we can use it in the medicated shampoo. If you want to prepare the medicated shampoo, we can use the SLS. Okay. See, when it is a hydrophilic surfactant because of negative charge present on the oxygen, this can be used as a foaming agent. We have previously discussed in the previous slide. Foaming agent should be hydrophilic in nature because foam nothing but it is a air in water system. If the water is a continuous phase, definitely we need to use the hydrophilic surfactant. Example of hydrophilic surfactant that can stabilize the foam is SLS. Sodium dodecyl sulfate, okay, sodium bisulfosuccinate. Next one is sodium laureth sulfate, SLES. SLES. What is the difference between SLS and SLES? Nothing but see, this is containing ethylene oxide. See, SLES, sodium laureth sulfate, that contain ethylene oxide group. If the ethylene oxide group is present in the surfactant molecule, that is having excellent foaming ability. Ethylene oxide group is responsible for the excellent foaming ability. Ethylene oxide nothing but hydrophilic in nature. If the hydrophilic, it can be easily soluble in the water, hence it can easily stabilize the air in water system. That is the foam. Next one is sulfated alkanol amides. This is also hydrophilic in nature. See why it is hydrophilic in nature means because of presence of hydrophilic group. One amide also hydrophilic group. Next one is this positive charged amine group along with alcohol groups. See this sulfated means this is sulfur content sulfate group. Alkanol nothing but alkane group. This alkane group. OL nothing but alcohol group. Next one is amide group is there. We can call this sulfated alkanol amides. See, these are the large hydrophilic in nature. These are the hydrophilic due to the presence of amide. Next one is sulfate, amine, and alcohol groups. So this can be used as a, when it is a hydrophilic in nature, we can know already that can be used for foam stabilizers in soaps and shampoos. Next one is glyceride sulfates and other sulfates. See glyceride. See, we people already know this is a glyceride moiety. This is a glyceride moiety. This is a fatty acid that is contained. If we have substituted sulfate group, we can call as glyceride sulfates. And to that sulfate, that oxygen sulfate group that contain oxygen, that is negative charge. If we have added positive charged ethanolamine, see why we are adding positive charged ethanolamine means this positive charged ethanolamine having less skin irritation property compared to sodium. So this is also used as a excellent foaming agent. It is hydrophilic in nature. Hydrophilicity because of ester group, alcohol group, a sulfate. Next one is amine group. Next one is alcohol group. This is hydrophilic, so acts as a foaming agent. Next one is anionic surfactants. Uses. See, what are the uses of anionic surfactants? See, we people already discussed anionic surfactants. That is monovalent soaps used for the stabilization of oil in water system. Okay, next one is divalent soaps can be used to stabilize the water in oil system. Also, these anionic surfactants used in the shampoos as a cleansing agent. Cationic surfactants used as a conditioning agent. Anionic surfactant molecules used as a cleansing agent in shampoos. But what are the major disadvantages associated with anionic and cationic surfactant is this cationic and anionic surfactants that will cause a skin irritation property. See, this cationic and anionic surfactant that will cause a skin irritation property because of the charge. So, in order to eliminate that skin irritation property, definitely we need to use the non-ionic surfactants. See, non-ionic surfactants do not have any skin irritation properties. Hence, we can use that anionic surfactants in the oral formulations and parental formulations. If you want to formulate the oral tablets and parental forms, we can use the anionic surfactants, but we cannot use the cationic and anionic surfactants because of its toxicity. That is the important point. Next one is non-ionic surfactants. Next one is non-ionic surfactants. surfactants, that is only sugar alcohols. Under the non-ionic surfactants, we need to discuss the glucoside. Glucoside nothing but sugar alcohols. See here, all these are ethylene oxide group, WXYZ. All these are ethylene oxide groups. How many ethylene oxide groups need to be there means total 20. Only 20 ethylene oxide groups should be there. Hence, we can call as a name 20. It contains 20 ethylene oxide, 20 ethylene oxide. Hence, the name tween, TWE. That is twe, En nothing but that 20 ethylene oxide or oxyethylene groups. Hence, the name tween. Span. See, span nothing but this is a sorbitan group. This is a sorbitan group that is treated with palmitic acid. First, that is treated with this fatty acid, that is palmitic acid. Hence, we can call it a span. This tween is hydrophilic in nature because of presence of ethylene oxide. Ethylene oxide is water soluble, hence tweens are hydrophilic in nature, but spans are lipophilic in nature. Span is lipophilic in nature. Tween is hydrophilic in nature because of presence of ethylene oxide. See these non-ionic surfactants that majorly contains ethylene oxide or propylene oxide. See, see if it is containing two carbon containing ethylene oxide, then it is lipophilic in nature. If it contains three carbon containing ethylene oxide, three carbon containing group is that is propylene oxide. Propylene oxide is lipophilic in nature. Propylene oxide is lipophilic in nature, but ethylene oxide is hydrophilic in nature. See, this oxygen will be easily solubilizes these two carbon moieties. This oxygen cannot soluble the three carbons. The capacity of oxygen is it can solubilize only two carbons. Since ethylene oxide is hydrophilic in nature, propylene oxide is lipophilic in nature. So next one is span. Already we have discussed this is lipophilic in nature. This is sorbitan. This group we can call as sorbitan group. This group we can call as sorbitan group. 1, 2, 3. See this what are this 1, 2, 3 means we can substitute the fatty acid at the place 1, at 2, and 3. We can call as a substitutions at 1, 2, 3 positions. See if we have substituted fatty acid at only first position, then we can represent 0. If we have substituted at first, second, and third position, then we can indicate that is 5. If 1, 2, 3 positions are get substituted with fatty acid, then we can represent that is 5. Tween. See, this tween is hydrophilic in nature due to the presence of ethylene oxide. Already we have discussed. See, this tween contains ethylene oxide groups. See, these ethylene oxide groups are there. How many ethylene oxide should be there? Means only 20. Hence the name tween. Here also same. If only first position is get substituted with fatty acid, OH group is substituted with fatty acid, then formation of ester, then we can represent only zeros. Tween 0, tween 20. If first, second, and third positions are substituted, then we can represent 5. Now we can get here. See, span 20 nothing but 2 indicates lauric acid. Lauric is a fatty acid that can be substituted. 0 indicates lauric acid is substituted at first position, that's all. Next one is 5. Span 25 nothing but lauric acid can be substituted at first, second, and third positions. Likewise for tween 20 nothing but 2 indicates lauric acid, 4 indicates palmitic acid, 6 indicates stearate, 8 indicates folate. See, twin 20 nothing but 2 nothing but lauric acid that is substituted at first position, that's all. 0 indicates the substitution only at first position. If we have indicating twin 25, this 5 indicates the lauric acid can be substituted at first, second, and third positions. This is the name nomenclature of spans and twin. See, this surfactant contains 4 hydroxy group. These hydroxy groups can be reacted with fatty acids. See, if you are adding fatty acid that contain only hydrocarbons to increase the lipophilicity. If you want to increase the lipophilicity, we can add only fatty acid. If you want to increase the hydrophilicity of that non-ionic surfactant span surfactant, then we need to add ethylene oxide group. See, what are the uses of non-ionic surfactant is non-ionic surfactants can be used as a detergents, wetting agents, emulsifiers, also used as a foaming agent. But because of poor solubility in water, we cannot prefer this non-ionic surfactants as a foam stabilizing agents. Next one is amphoteric surfactant. Amphoteric surfactant, the best one is lecithin. Amphoteric surfactant nothing but that contain both negative charge and positive charge. See, at the isoelectric point, means at that particular pH, isoelectric point nothing but that is a pH. That is pH at pH 7, both positive charge and negative charge can be displayed. This lecithin will shows both positive and negative charge at pH 7 only. If at pH above 7, it will shows predominantly negative charge. If below 7, it will shows predominantly negative charge. That is the isoelectric point. Isoelectric point nothing but the pH at which the pH at which there is a exhibition of both positive and negative charge. We can call it the isoelectric point. See, the lecithin is having isoelectric point that is at pH 7. Hence, this lecithin can be used in the parental formulations. Lecithin can be used as a surfactant in the parental formulation because it is having isoelectric point at pH 7. Because pH 7 is neutral in nature. And this amphoteric surfactant that is having good biological compatibility means it will not show any toxicity to our bodies. Next one is low toxicity. See, this is about the different kinds of surfactants. This is about different kinds of cationic, non-ionic, anionic, and amphoteric surfactants.